The heartbeat of modern human existence heavily relies on the flow of electricity. Every single day, you use something that requires electricity. The electricity you use to power your phone, your lights, your microwave, or basically any electronics is coming from possibly hundreds of thousands of kilometers away, and it was generated just some seconds ago. But by the flip of a switch, let there be light. Get ready to uncover the secrets of the electric grid, understand the language of volts and watts, and even learn how to create your own self-reliant renewable power system. But first, let's shed some light on the burning question. How exactly does electricity find its way to you? And by the way, what causes blackouts? Good questions. Very good questions. Powering an entire nation is an insanely complex task, managed through what is called the electric grid. An electric grid is an efficient network that brings together the power generation, transmission, and distribution systems that deliver electricity from power sources to consumers. Electric grids are very large networks that can stretch across an entire continent. Unlike water systems that have reserves filled with water, the electricity running through the grid and powering your house right now was produced just moments ago. It is generated on demand. This is the insane complexity of running the energy-hungry electric grids. Let's see how the grid works. As mentioned, an electric grid is a masterful dance of power generation, transmission, and distribution. In Kenya, licensed producers, distributors, and transmission utility companies play crucial roles. Power producers generate electrical energy, then they sell it to Kenya Power, who oversees transmission and distribution. EPRA, the Energy and Petroleum Regulatory Authority, monitors and regulates the process. But let's start at the very beginning. Power generation. Power plants produce electricity, and the power plants themselves are fueled by various sources like coal, natural gas, or nuclear, and also renewable sources such as solar, wind, and hydro. Electricity at these plants is typically generated at high voltages. Voltage is the push that makes electricity flow. It's like the pressure in a water pipe that makes water come out. The actual flow of electricity is called current. It's like the amount of water flowing through the pipe. When you turn on a light switch, the current flows through the wires, lighting up the bulb. But how fast do you think the electricity travels? Stay tuned. The largest electricity producer in Kenya is KenGen, which is owned by the state and operates various power plants including hydroelectric, geothermal, and thermal plants. Other local producers include Lake Turkana Wind Power Plant, Olkaria Geothermal Power Plant, among others. If you want us to delve deeper into how these plants work, please leave a comment below. After power generation, it needs to be transmitted. This is where Kenya Power and Kenya Electricity Transmission Company KETRACO come in. They develop and maintain infrastructure required for transmission. High voltage transmission lines carry the electricity from power plants to substations over long distances. The high voltage is necessary to minimize energy loss during transmission. Here is a fun fact before we continue. When the voltage on transmission lines is very high, it can ionize the surrounding air, causing something called a corona discharge. Whenever you hear this sound around power lines, it is as a result of the corona effect. This phenomenon leads to energy loss. Moving on, substations receive the high voltage electricity from power plants and transform it to lower voltages suitable for distribution. Transformers at the substations step up or step down the voltage as needed. This lower voltage electricity is then sent out through distribution lines. Distribution lines deliver electricity from substation to homes, businesses, and other consumers. Transformers along the way further reduce the voltages to levels safe for household use. Distribution lines are smaller than transmission lines and carry less power. Throughout this journey, Kenya Power has control centers to monitor the flow of electricity, manage generation to match demand, and respond to disruptions or fluctuations to maintain grid stability. All the various components that make up the electric grid must be reliably coordinated to prevent overloads and blackouts. Later in this episode, we will discuss what causes blackouts. The final part of this journey is where you come in as a consumer. Consumers receive electricity at the right voltage for their energy needs for lighting, heating, cooling and powering electronic devices. An electricity meter is used to measure and record the amount of electricity consumed. This is how electricity is measured. A watt measures how much power an appliance uses. A 100-watt light bulb uses more power than a 40-watt light bulb. 1000 watts make up 1 kilowatt. Electricity is measured in kilowatt hours. It tells you how much electricity you've used over time. It's like how many kilometers you've driven in a car. If you have an appliance rated 1000 watts, which is 1 kilowatt, and you use it for 1 hour, you will have used it for 1 kilowatt hour of electricity. If you use it for 2 hours, you will have used 2 kilowatt hours. By now, I'm sure you see where this is going. If you use a 1.2 kilowatt appliance for 3 hours every day in a 30-day month, the estimated monthly consumption is 1.2 kilowatt times 3 hours times 30 days, which brings about 108 kilowatt hours. Some of the biggest energy spenders in an average household are water heaters, microwaves, ovens, refrigerators, and heating and cooling systems. Always check the energy rating of the appliances you buy. Energy efficient appliances can help you reduce the overall energy consumption. Cheap can be expensive. What you do with that information is entirely up to you. In the average Kenyan household, we use the prepaid token system to purchase electricity. It allows consumers to purchase a certain amount of electricity credit in advance and load it to the meter. And just when you're done loading your token code, blackout. Let's shed some light on the top 3 causes of power blackouts right here in Kenya. Cause number 1 is generation shortfall. Sometimes, the demand for electricity exceeds the available supply. This can happen due to unexpected outages in power plants, maintenance work, or a sudden increase in electricity consumption during peak hours. Peak hours are normally in the evening around 7 to 9 p.m. when people are back at home, so lights and everything else is turned on. Since there are no power reserves storing extra power, the generated power is used up almost as soon as it's produced. Number 2 is transmission and distribution challenges. The complex network of power lines and substations faces challenges like equipment failures, maintenance issues, vandalism, or damage caused by accidents, weather, or even animals. Cause number 3 is weather and natural factors. Unpredictable weather including heavy rains, lightning, and strong winds can lead to damage to power infrastructure. For example, heavy rains can cause floods that disrupt power lines, while lightning strikes can damage equipment. Did you know that the myth about lightning never striking the same place twice is just an electrifying tale? Lightning can be quite the repeater when it comes to choosing where to strike. On average, lightning strikes the earth about 8 million times in just one day. Lake Maracaibo in Venezuela has the highest lightning rate in the world, with an average flash rate of 389 per day. Moving on, let's talk about renewable energy and how you can create your own electricity system. Renewable energy sources are natural and abundant forms of energy that can be continually replenished within a relatively short period. These sources including solar, wind, hydroelectric, geothermal, and biomass harness energy from sustainable natural resources. You can set up a solar system that is off the grid and self-reliant. An off-grid solar setup works by harnessing energy from sunlight through solar panels. The panels convert sunlight into electricity, which is stored in large batteries for later use. During the day when you are out of the house, the solar system charges up the batteries. And at night when you need electricity, the batteries power up your house. Then you repeat this every day. These systems are quite costly, so that can be a disadvantage. They also do not do well in cloudy places as they rely on good sunlight coverage. More advanced systems like the Tesla Powerwall system in the US allows you to sell excess power from your batteries into the grid to help them supply power where it's needed the most. Watch out for our video on technologies we should have in Kenya. And subscribe to this channel to never miss our videos. Before we wrap up this electrifying journey, let's finally have a look at the statistics of energy production and consumption in Kenya. These are based on the latest statistics, most of which are available on the Kenya Power website. In 2022, Kenya generated nearly 13,000 gigawatt hours of electricity. A gigawatt hour is equivalent to 1 million kilowatt hours. Around 87% of this energy was produced from renewable sources such as hydroelectric power plants, geothermal, solar, and wind. Kenya is the leader in Africa as far as geothermal energy generation goes. We are number 7 in the entire world on the same list. Access to cheap and affordable electricity has been identified as one of the key drivers for Kenya to attain its Vision 2030 goals. However, still, less than half of the population have access to reliable energy. In the same year, Kenya had the 7th most expensive household electricity prices in Africa. Kenya Power has always been on the spotlight over frequent outages and yet high cost of energy. And so, our electrifying journey comes to an end, but the spark of knowledge and curiosity continues to shine. And here is another mind-blowing fun fact for you. Did you know that electricity travels at nearly the speed of light? That's right. It zooms through those power lines at an astonishing 300,000 kilometers per second. To put that into perspective, in just 1 second, electricity will have gone around the equator 7.5 times. Yes, you heard that right. Electricity could make that journey faster than you can blink. The story of how Kenya Power delivers electricity to our homes is a testament to human ingenuity, innovation, and the power of collaboration. Every time you switch on a light, charge your devices or power up your appliances, remember the incredible journey that brings the energy to you. If you've enjoyed this adventure, don't forget to give us a thumbs up, share this video with your fellow curious minds, and hit that subscribe button to stay tuned for more captivating explorations. Do you have questions, electricity stories to share, or myths you want debunked? We'd love to hear from you in the comments below. Also follow us on our social medias to keep the conversation buzzing. Thank you for joining us on this illuminating journey. And as we continue to light up the path ahead, let's keep exploring and learning. See you in the next one.